Hello and good morning. I'm Alexandra Seshislavkovich, Professor of Statistics and the Associate Dean for Research in the Eberly College of Science. It is my honor and has been my honor and pleasure for the past 6 weeks welcome you all to, and this time, final week of the 2026 Ashtekar Frontiers of Science lecture series. This popular public winter series is now in its 32nd year. The series was founded by Ashtekar in 1995, soon after he arrived at Penn State as the director of new research center that is now the Institute of Gravitation and the Cosmos. It owes its successes to tireless efforts and meticulous planning by Barbara Kennedy, who presided over the series during its first 25 years, making it one of the most successful science outreach events in central Pennsylvania. This year's lecture series, titled Unexpected Pairings, addressing today's biggest societal questions using different disciplinary approaches, has explored how researchers from different disciplines and from the college's 7 departments leverage wide-ranging methodologies and theoretical approaches to tackle some of today's biggest societal questions and pressing scientific issues to help shape the future of science, health, and humanity. Each of the past 5 lectures featured 2 high-level overview talks on topics including origins, medicine, resources, materials, and climate. If you missed one of the previous weeks, you can find the recordings of those lectures at science.psu.edu/frontiers. Today, for our 6th and final lecture, you will hear from 2 researchers on another essential topic for our college and to our society, the topic of education. Today's first lecture, titled The Importance of Self-Regulated Learning in the Undergraduate STEM Classroom, is being presented by Jennelle Malcos. Jennelle is the Associate Dean for Undergraduate Education and a full teaching professor of biology in the Eberly College of Science. Her experience teaching in large introductory biology courses prompted Jennelle to explore how to better help students learn and lead to her collaboration with Rayne Sperling, Professor of Education, starting in 2017. Jennelle has served on Faculty Senate for several years, oversaw the biology undergraduate student living learning community, the biome, and has active research focused on student self-regulated learning in science courses. She has led the college's Learning Assistant LA program, one of the largest efforts in the country. Congratulations. The second lecture, titled AI Support for Teaching and Learning at Scale, will be presented by Matthew Beckman. Matthew is an associate research professor in the Department of Statistics, of course, my favorite. Department. His research interests include statistics and data science education, especially where these fields intersect with assessment, development, and educational measurement. Matt is currently the executive director of the Consortium for the Advancement of Undergraduate and Statistics Education. Following the lectures, graduate students and Science Achievement Graduate Fellows, Morgan Vincent and Katie Yen, will lead a moderated question and answer session with Jennelle and Matthew.
I wanted to give a little bit more information about the Learning Assistant program that was mentioned because it's a really cool program. Since its launch in 2012, the program has grown from 81 Learning Assistant positions in 5 courses to more than 44 courses spanning the Eberly's 7 departments. This is a stat from 2022 and 2023. And so now nearly 10,000 undergraduate students are impacted by the Learning Assistant program each year. And students who attend office hours with learning assistants scored 20% higher on their exams in one pre-calculus course. So I think this is a really cool program, but it's different than a TA program. So TAs are there, they help the teachers teach. Learning assistants are there to help the students learn. And so it's a really, really cool program.
Well, Sasha, thank you so much for that introduction and appreciate that. Also, I would really like to take a moment to thank the college leadership for inviting Matt and I to present in the seminar series of Unexpected Pairings, including science education. Our inclusion not only helps to bring attention to the importance of this topic, but also to help show the value that the Eberly College of Science has in excellence in teaching and moving forward our educational mission. So I'm really honored to be part of this and really excited to share this with you all today as a slightly different kind of flavor of research that occurs in our college. So my talk will have 2 parts. Part 1 is an introduction to STEM education, just in case this is a new topic to you. What does it mean? What does it look like? So I'll talk about 10 minutes for that introduction. And then I'll transition into my research, which involves self-regulated learning in the classroom, and share one example project that's in a collaboration with Rayne Sperling in the College of Education. So that's the plan. We feel good about that? Yes, we're good? All right. Thank you for being here also on a beautiful February day when it's going to be 60 degrees outside. So we'll get you out so you can enjoy the afternoon, right? All right, so we're going to start with what is STEM education research and its importance. All right, this here is a picture of a forum classroom. Anybody been in forum? Yes? All right, it's a love-hate relationship with instructors. So I personally love being in forum. Other people hate it. But it is a typical classroom at Penn State. This is maybe a chemistry class. Looks like maybe math. All right, so it's about 200 to 300 students. You could see different things happening in this classroom. Sometimes it's more traditional lecture. Sometimes TAs or learning assistants may be included. So you'll have more action, more activity occurring in the classroom, maybe small group projects, maybe worksheets. So lots of things can happen in this setting. This is one example setting, but we also have small classrooms here at Penn State, 25, 40 students. We also, if you can believe it, have a bigger classroom. Any thoughts of what the biggest classroom can hold at Penn State? I hear 1,000. Anyone want to go above or below that? I believe the actual number might be 728, but that's in 100 Thomas. So that was a classroom I taught in for many years. So if you can imagine having 700 students, a very different environment than 40 students. And not only do we teach in classrooms in the Eberly College of Science, because of the nature of our work, we also get to focus on experiential learning and lab settings. So this is an example of a lab classroom. This is from the Biology First Year Research Initiative, where students are exposed to a lab that's set up like an actual research lab, and they do actual research with a professor and get that experience. So it's very different than what you would expect happening in a lecture hall, right? But we also have classrooms that are in the field. We have classrooms that are in different countries, right? Lots of different settings. Now, on top of the fact that we teach in different locations, we also teach many different topics in STEM, right? Cell biology, look at those beautiful chromosomes. That's my field, so I get excited to look at the chromosomes. And those beautiful microtubules. From cell biology to chemistry to measuring forces in physics, mathematical quantitative sciences, anatomy, physiology, structure of organisms, gravitational fields. All these wonderful topics can come up in the classroom. So when we think about STEM education research, we're really asking this question: how do students learn in the STEM context, right? And that can include the environment, it can include the topic, and most commonly includes both of them together, right? So that's the focus when we look at STEM education research. How are students learning in this specific setting with these specific topics? Now you might say, well, as an instructor, where do you fall within that spectrum of research? So I'd like to introduce the idea that teaching can kind of be the starting point for thinking about STEM education research, reflective teaching. This could be any instructor in the classroom giving a lecture, doing a presentation, having an activity, and then just asking, how'd that go, right? Being reflective with your practice. This is going to be context specific. It's going to depend on what happened in that room that day. Also student specific, because as you know, student populations change, right? One class can be very different from the next class, can be very different from the next class. So having both the context and the student population is important. But this is the very beginning of exploring how students learn, being a reflective teacher. Now, as we continue down the, wrong button, sorry. The spectrum or the range here, in the middle, we have a field that's called the scholarship of teaching and learning. This is where we're taking reflective teaching and formalizing it into more of a research question. So what's different between reflective teaching and what we call SOTL, if you want to be cool, it's SOTL, okay, just mental note. How do students learn in my classroom? So we're carrying over that context and we're carrying over the fact that it's student specific, but we are becoming more formalized in the fact that we're going to ask a specific question and we're going to be collecting data, analyzing that data, and having some results. Again, the results of whatever that question are specific to my classroom, specific to my event, specific to what was happening, right? So you're staying within kind of the population that you're working with. Where we're going to be looking today, though, is called discipline-based education research, or again, if you want to be in the Cool Kids Club, DBER, discipline-based education research. In this category, we're going from the reflective teaching, we're keeping it context and student specific, we're asking a specific question, we're collecting data. The difference is, though, is we're going to try to generalize those results. What I do with the students that are part of my experimental setup, I hope to apply those results to another school, in another place, in another part of the country, or even internationally, right? We're generalizing the results to try to help advance STEM education on a large scale. So that generalizability is really what becomes important when we look at deeper work. And again, I put a star there because that's kind of where Matt and I are focusing today with our conversation. Sound good? Okay. All right. So we're asking questions about how students learn. We're going to try to generalize it. There's kind of two different ways people can become involved in deeper work. All right. So the first one I categorize as science first, education second. That is my category. So I'm a cell molecular biologist that studies plants. And through my work in the classroom as a teaching professor, I became very interested in how students learn. I was unsatisfied with the results in my classroom. Like, what is going on? Why aren't they listening to me? So that drove me to ask questions about what am I doing that I shouldn't do? What am I doing that I should do? And how can I make this experience better for students? And through those interactions, I became involved with a partnership in the College of Education. At first, I was just a user of their tools. But then I was like, oh, these are cool. There's theories. I can learn things I can apply to my teaching and grow in that direction. So I am a scientist first, but then came to education through that passion, and now use that work for my research. We'll hear from Matt next, who I put in as integrated with education. So he's a statistician. Well, I don't want to define him, but generally speaking. But his PhD work is in QME, quantitative methods of education. So his actual PhD foundation integrates education into the context of the field. All right, so he has a different background, different approach because of his foundation in that educational pathway. Did I do okay with that? Yeah, okay, thumb from out. So we have both approaches, but in the end, we're all working in this deeper field to help advance STEM education. Just wanted to share a little bit about those involved at Penn State. We have many people and a variety of examples, so I can only fit a few in the slide here. There's no my favorites. These are just some that I picked. In the yellow, we have Nate and Louie. They both kind of fall under my category of science first, education second, both mathematician and physicists interested in different aspects of learning. And then I shared an example here of Neil and Beth, who are also in the blue category with Matt, where they have their education founded in STEM research, STEM education research, and have grown their pathway in that direction. So just two sets here of examples of those different pathways. I did want to include this picture, though, which is a little bit more comprehensive, of 20 of us who got together a few years ago that were all different parts of that spectrum interested in becoming involved in STEM education research. So it's a varied group, all different disciplines, all working together. And the point of this workshop was to help advance people's individual interests of how they can either go into SOTL or go into DBER and continue expanding their work. So we do have a large group interested in this field here at Penn State in the Eberly College of Science. Again, one of the reasons I'm very happy to be here to share on behalf of all these the work that we've been doing. So that's a little bit about the landscape and the intro to STEM Ed. Just two quick slides about the value. I'm sure I don't have to convince you here in the room that STEM education is important, but sometimes looking at the numbers can be helpful. So according to NSF, right, about 25% of our workforce in the United States is either directly or adjacent to a STEM education when entering into the workforce, so a large part of the population. With that said, it's predicted to see a 6% increase in the STEM occupations workforce compared to 3% overall over the next 10 years. So we have a demand for successful STEM graduates to be able to fill this workforce pipeline, right? So this education component is really important in terms of producing students that can actively and successfully enter into that workforce. Also, if you look at the NSF STEM Education Directorate, which is a funding agency, one option of a funding agency for this type of work, they have a direct mission here, right, to invest in high quality research and promising practices in STEM education to ensure an inclusive, well-prepared STEM workforce and STEM literacy, right? So we have not only a demand in the nation, as well as direct mission statements from our funding agency for this type of work. So there is value across the nation for this to continue. And I did a little digging just as a point of comparison, looking at the NSF discretionary funding for fiscal year 2025. And the STEM Edu Directorate is about 13% of the money that they'll send out for research projects. Now, not everything in the Education Directorate is higher education. We share it across K-12, workforce development, all different programs, but 13%. I will also mention that in the other 87%, there are opportunities for higher education research, but it's easy just to show one slice of the pie here. So we're going to go with the 13%. All right, we're going to do prices right. All right. So we're going to look at the Biology Directorate, which is biology education. Do we think it's higher or lower than the 13% given to STEM education? So the Biology Directorate is about 8% of the discretionary funding, so it's lower. MPS, Mathematical Physical Sciences Directorate, higher or lower than our 13% in STEM education? 17%, so it's higher. So I just like to show this because there is value. STEM education is nestled right in between those two. So there's money available for a research enterprise to have faculty participating in this research at a university like Penn State. All right, so we are definitely in the middle here where we look at education research. So there's your intro, a little bit about the importance and a little bit about the value. I'm now going to switch over a bit more to my work. All right, so I'm coming back to the forum here because I've taught in the forum for courses. I've taught, like I said, in 100 Thomas, where we have 600 students. And in the beginning, when I first started teaching, it was me versus 600 students, basically, 650. And I was like, how do I help my students? This is a huge classroom. I was teaching Introductory Anatomy and Physiology when I first started teaching, so A&P 1 and 2, human body stuff. These are first-year students, fresh out of high school. You know, I was hoping they'd shoot for the moon, do awesome, be, excellent students. And what I soon realized after teaching, focusing on the content, making sure everything was perfectly described and they could, follow my worksheets. But the types of thoughts that I were having about my students weren't really about the content. It was about the process of learning, right? So if you look at a few of these, right, how do I help my students be more reflective, right? When they make a mistake, they don't just walk away. They say, well, why did I make that mistake? That's what I want them to do. Most of them are just like, I got a 62, my life is over. Okay, next test, right? But how do you become more reflective about the mistakes that happen, right? How can I prevent my students from cramming? That relates to how do I instill good study habits, right? Not just telling them because it doesn't always work. I have to be more creative. How do I help my students use the effective study strategies? That goes with don't just highlight. How many of you had the experience of reading something and you're reading and you're like, oh, that Stranger Things episode was awesome. Oh, yeah, and don't forget the grocery list. And you look back, you highlighted your whole page and you don't have any recollection of what you just read, right? So helping students pick the successful study strategies, right? Oftentimes we assume that students know how to do that. That's a big assumption because we know many students can't do that or do not know how to do that effectively. So looking at these types of questions has led me to kind of jump into self-regulated learning, which is really the underlying theory that helps address those concerns. So before I even talk about self-regulated learning, quick mention of self-regulation. How many of you all made a New Year's resolution? Spend a few months. Steve made one, Morgan made one. Anyone else make a New Year's resolution? No, other people didn't even bother. Like, no, I'm gonna. So I saw a few hands. Steve, are you still adhering to your New Year's resolution? You give me a thumbs up. Awesome. Morgan, are you adhering to yours?
Several, so some of them.
So Morgan says she had several, but some of them she has. Anyone else adhering to their New Year's resolution? All right. Okay. Well, Steve, as the one who has successfully adhered to it, I am guessing has some great self-regulation skills. Do you want to share what your resolution was, Steve? You don't have to. You can say no. He's like, no, absolutely not. All right, but let's just say let's say my New Year's resolution was to exercise, right? That means I have to get up or go in the evening, whenever I have to set a schedule, I have to be motivated, I have to have a plan of what I'm gonna do, and I'm gonna keep doing it, regularly. That's all examples of self-regulation. We can take that regulation and just apply it to learning. So that's what self-regulated learning is. These two quotes kind of summarize two of the main parts I just want you all to understand. The first quote kind of shows us that self-regulated learning has multiple components. So I'll talk about that in a second, right? So it has multiple components that play a role. The second quote It's really the outcome. If you're a self-regulated learner, you can become a lifelong learner. You can transfer it to other disciplines, other parts of your life, and you can be successful, right? And I think we'd all agree we'd love our students to be able to do that, right? Not only walk away with the content, but the ability to learn their whole entire life. And that's really the goal with self-regulated learning. This was a picture or a graph diagram that I first saw when I was starting to learn about this. That really stuck with me my whole entire career, and I always come back to this one because it's nice and simple. Many different models exist. This is a nice one though, because it shows us that for self-regulated learning, there are three main things we need to worry about. Number one, cognitively, you have to be able to learn the content. You have to encode it, which means you have to be able to read it, study it somehow, and get it into your brain. There's lots of different strategies you can use for that, but that's an important part of learning, the cognitive strategy part. Second, you have to be able to monitor how that's going. Am I actually learning it? Do I know it? If I don't know it, how do I learn it? So it's metacognition. It's the next step. Not only do you have to learn it, you have to monitor how that learning is going and make adjustments successfully. Finally, number three, you have to be motivated. If a student is great cognitively, great metacognitively, but has no motivation for a topic, they're not going to care enough to do a good job with the other two. So the motivation piece is critical when we think about successful learning. So those are the three things you need to just kind of keep in the back of your head. Have to have good cognitive strategies. You have to check on those strategies to make sure they're working, and you have to be motivated to do that. If you can manage those three things, you can be a self-regulated learner. Unfortunately, many of our students do not have all those three things working at high capacity. So as instructors, we're trying to think about how can we get all those three things working together so that they can maximize their learning in our classrooms. So the other two things just to mention about self-regulated learning, kind of did already, it can be taught. So if students haven't practiced those skills, they can be taught. These are from previous research projects. So you can teach someone how to be a self-regulated learner, and those that are self-regulated tend to have higher outcomes in classes. They tend to be retained better in the sciences, and they also have higher satisfaction and self-efficacy, which is also known as confidence in their academic journey. All good things that we want our students to have. All right, so the goal of the group I work with, the part that I work on, is that we wanted to develop a technology-based tool with an underlying theory, which is a self-regulated part, regulated learning part, that will allow students to practice SRL, self-regulated learning, within the context of a course. So the group I work with is developing a tool so these students can be constantly practicing this while they're learning the content. This is actually quite important for interventions in education. When the intervention is embedded within the course, it tends to be more impactful than when it's an intervention that's done on the outside and then the student has to jump in and figure out how to use it themselves, right? So you might say, let's just teach all students about self-regulated learning and they'll just apply it. Sounds great. Doesn't work so good because they don't know how to apply it. They need that guidance. So teaching it within the class context can be more impactful, which is what this technology tool is meant to do. All right. So the underlying framework we work with is called the Success Through Self-Regulated Learning. You'll see three of the components we already talked about. So this is the framework developed by Rayne Sperling in the education psychology department that I work with. You'll see the three: metacognition, strategy use, which is the cognitive piece, and motivation already here. The important things that we've added into this framework is that the content is important, like what they're learning in that class, as well as what we call management. This is just being able to use the resources of a class well, being able to understand when the tests are, being able to understand when office hours are, all those like managing your time pieces that are important as well. So all of these interact in this framework. And what does the actual intervention look like? Well, what we help instructors do is build prompts, little questions. This was designed during the Twitter era. Before we had X, we had Twitter, right? Where prompts were very short and answers were very short. So it was meant to be quick, reminding students about SRL practice, having them respond back to the instructor, and a constant reminder as the class continues, right? So the instructor will work with this. I'll show some example prompts in the next slide. These prompts are delivered through the course management system. We use Top Hat here at Penn State. So during a semester, students might get 2 to 3 prompts a week related to these topics to help nudge them into self-regulated learning. So we call them nudges typically. So we're going to nudge them into these good practices to become self-regulated learners. Some examples here. Strategy use. Creating an analogy between today's content and the solar system will help you learn. Generate an analogy and submit it below. So we're providing examples of research-based techniques that help with encoding information, allowing them to practice it, and the instructor can see those results. For metacognition, you just received the results of your first test. What types of questions did you get wrong, and why were they tough for you? So forcing them to reflect about their performance and think about the next step. Motivation. The Bio 110 test is coming up next week. What is your study plan to prepare? Including a study group can help with accountability and practice. So building their confidence that they can do well if they plan and prepare. And finally, management. The learning assistance offices are posted in Canvas. Can you identify an office hour that works with your schedule? So helping nudge them to these good practices. You'll notice there may be some overlap in nudges. When nudges can use multiple categories, they're even more impactful. So we help instructors think about how we can incorporate multiple kind of parts of this into a single nudge. So in the last two or three slides here, I'm just sharing one example study that came from my project. This was presented in 2002 at the American Education Research Association. It was in my anatomy and physiology class. The big question here at the bottom is what you're probably interested in. I was asking, does incorporating SRL practice aligned with learning activities improve outcomes and self-regulated learning in the class, right? Big questions. That's what I started off with, right? I wanted to improve it. Am I actually doing it? Let's do some data analysis to see if it's actually working, with the intention of generalizing it. So we've already looked at this with physics students as well. We're expanding it with that deeper lens, right? So the setup of this study, to give you an idea of what it looked like, my class did out-of-class assignments. So this is, again, anatomy and physiology, so we're focusing on the nervous system. So they had some out-of-class work. In class, they did small group worksheets related, right? And then we had the out-of-class SRL prompts. These are the nudges. So they saw this course material, and the nudge was, sometimes in Bio 161, we focus on the details. However, understanding the big picture is equally important. In one or two sentences, can you explain why neural circuits are important to our physiology? This technique is called summarizing or elaborative integration, where students put complex things together, right, making those connections. This is an effective cognitive strategy, so we want them to practice that and not just say, go study, because they don't often know what it means when you say go study. So giving them this prompt actually helps with that process. This is a general setup. We wanted to see how these things integrated to affect class performance and self-regulated learning. In this specific example, we measured motivation, which is self-efficacy, the ability to feel motivated to do something. This is that we did a path analysis. So this looks complicated and scary. Maybe, I don't know, is anyone scared? No, you're okay. I was scared. I'm not a statistician. I'm a biologist, so I work with my group who has deep statistics knowledge to help with this. But all we're doing here is setting up the variables and how they interact with each other. So the first variable was that students took surveys about self-regulated learning components, including self-efficacy. So we did a pre-survey and a post-survey about how their efficacy felt towards learning biology. So that's the self-regulated learning part. Here's the prompts. We had 4 different prompts we looked at that were integrated with questions on the test and the test itself. So we're following a path of relatedness. Do the prompts have a relatedness to the questions on the test and how they perform and the overall test? Ultimately, we look at the end where we have the post-test self-regulated measure and then the final score there. So using statistics, we're going to ask if this model fits. Does this work? Does the data support that these are related to each other? If the model fits, I'm like, yes, my work is I'm doing well. What I'm doing in class, the prompts are aligning with their success on the test, which is a great outcome, right? So we do the statistics, we figure out if all these paths align, and we found that it was a good fit. So yay! I did not put the statistical table up here because it's huge and lots of arrows. But when it's a good fit, that means that our hypothesis, the model we outlined, does suggest that the relatedness between those variables exists. So that is a good outcome here. What we're doing with these prompts with SRL is actually helping. Students' response quality to these prompts had positive effects on the overall performance, including the questions and the exams, and their efficacy improved over time through using these prompts. So not only do we impact the performance, we impact their ability to be self-regulated learners. both things we hope to achieve. The overall implications of this is that this intervention was enough to affect the performance. Educational psychologists care about this because they learn in theory and they want to apply it. For biology, someone like me, an instructor, when I align my activities, they actually did have related impacts on the outcomes, which is really important. And then collectively, being able to take theory, implement it into instructional design, really important then to have that in the classroom. So we're actually making changes to how we teach based on these types of outcomes and integrating this information. In our future directions, we're looking at faculty interviews to understand how the faculty change their perspectives about what learning means in the classroom. We're looking at the relationships that build when faculty ask these types of questions. And we're hoping to incorporate artificial intelligence into a system that can help generate prompts for students rather than instructors. So kind of addition to what the instructor can do, bridging that gap. So thank you to my Nudge team. This is Rayne Sperling, Louis, Song, and Ing, great collaborators, lots of expertise being shared and great friendships through that group. So they're the ones that have helped get us to this point with our project. And thank you all for the time and listening a little bit about self-regulated learning. So thank you very much.
Thank you so much, Jennelle. That was great. So thank you all for coming out today, especially, like I said, on such a beautiful day. So while they're getting set up here, I just wanted to share one or two Eberly College of Science facts. Jennelle gave that beautiful landscape of STEM education, the importance of STEM education here today. And I wanted to share a couple of facts here. So the undergrad program here in Eberly that Jennelle helps to oversee and drive the curriculum for, we are the STEM backbone of Penn State. So not only do we teach Eberly College of Science students, we teach all of the other students their core science courses. So that's, more than 90% of all students, 42,000 students that walk onto this campus as an undergrad, take our classes. And a couple of facts then on our students themselves. So students, Eberly College of Science students who go into our majors, 25% of our Schreier Honors College students are enrolled in Eberly. That's huge. Of all of the colleges here, 25% of all those honor students are in our college, which is pretty amazing. And approximately 92% of all undergrad students who pursue a major in our college graduate. That's a huge number, and that's really, really critical to their, the success of scientists in the nation. And then about 50% of the graduates, they enroll in graduate and professional programs. So they might go on to get their master's or a PhD or go into medical school or some sort of health profession. And the other 50% have careers in companies like AstraZeneca, Deloitte, Highmark Health, and the list goes on. So I just wanted to give a little bit of context of, the wonderful education that is going on here in our college. I know typically these talks are looking at research, and I think it's really special that we're able to look at the STEM education research today. And then without further ado, we're going to go into our next speaker, Matt Beckman.
Thanks so much. Great. Well, thanks. As Jennelle mentioned, it's an honor to be part of the seminar series, and thanks to all of you for being here to kind of learn about this work and share with us. So I wanted to share with you some work about AI support for teaching and learning, and in particular at scale. So Jennelle made this point pretty effectively already, but the learning environment matters. These are two classrooms that I teach in. Jennelle alluded to the one on the right. That's the largest room on campus. And to be fair, there is a human for scale, but it's a tiny human. So that's... but I teach in both of these rooms, and I teach in the room on the left. And these students, they get a lot of feedback from me. I get a lot of individual interaction with students. And this was a computer programming class for data analysis that I teach regularly. And I could look at their code. I could give them direct feedback on their code and help them to evaluate where their learning trajectory is and how to move towards a more complete understanding. On the right, of course, I'm trying to do all the same things, but it looks a lot different when there are several hundred students in the room simultaneously. And traditionally, the kind of approach in these large enrollment classes is that we look at the education research and we see what sort of things have been shown to do well for teaching and learning. And we do our best to extrapolate. But much of the research is born out of small interactions, case studies with individuals or small groups or small class environment. And we just try to do something that feels similar, maybe smells like it in this large enrollment environment. And so sometimes that goes more smoothly than others. And a lot of the work that I'm interested in sharing with you today is on the subject of formative assessment. Formative assessment is for learning. So summative assessment is when people hear assessment, they think of having grades assigned and this kind of thing. Summative assessment is more about measuring the learning outcomes. Formative assessment allows students to have feedback if they're keeping up with the key ideas that are going on in the lesson. It gives the instructor an opportunity to identify if individual students are kind of at a different point in that learning trajectory. And it also lets the instructor get a sense of what's happening in the room. Is this, going swimmingly and we can sort of speed along? Or is there some kind of incomplete understanding that we should address and slow down as a group? And so this allows the instructor to change what they do next. That's what formative assessment does. And this looks quite different, as you can imagine, based on the learning environment that we're interested in. And so I'm going to talk about how AI tools can be used to support teaching and learning at scale in this type of a context, and specifically for formative assessment. But it is useful to talk a little bit about where we've come from and kind of where we are today along these lines. And so it's been, a long-running kind of topic of interest of how can we bring technology to support education. And I'll start in the middle box that B.F. Skinner, a famous behavioral psychologist, had introduced this idea of teaching machines. And each student in the classroom had their own personal box. It looked kind of like a typewriter. And it would show prompts that the student would respond to with a pencil and paper. And they would push a button to reveal the answer to the prompt. And if they were correct, they marked it correct, and then they would move on to the next thing. If it was incorrect, they would mark that, and it would kind of go back in the hopper that they would see it again but it was about these kind of baby steps, very small incremental changes. And if you know much about behaviorism in that branch of psychology, that was something that Skinner was very famous for. And people were wondering, is this going to replace the teacher? And he's very clear in his kind of work introducing this. He has a paper in Science that was in 1958, a few years after this. He says, no, we're not trying to replace the teacher. We're trying to shift the emphasis that the teachers and the students have as their focus. So students can personalize the learning trajectory. They can learn at their own pace, and they can tailor it to their own understanding. The teachers can meet students where they're at with more personalized education. And so it wasn't about replacing the teacher. The teaching machine was about personalizing education. So we come now to kind of the more recent history. The first chatbot in kind of as we know them is called ELIZA. ELIZA was text on the screen. So you can see the Z is I was going for that. The Z is made of Z's. It was just text on the screen. There weren't anything else fancier than that. But it was developed by psychologists, sort of for psychotherapy. Like it adopted a form of psychology that you would tell it kind of, how are you doing today? How are you feeling? And it would take what you've provided as input and sort of repackage and mirror it back so that you could be prompted to go deeper. And that's what ELIZA was intended to do. Artificial intelligence captured kind of the public interest when IBM's Deep Blue defeated Garry Kasparov in 1997. I think I was in 7th grade, and I knew about this. Like, it was a big deal. That in 96, I left that one out. But in 96, Garry wins. But in 97, Deep Blue had made up some lost ground. IBM Watson defeats Jeopardy champions Ken Jennings and Brad Ritter head-to-head in Jeopardy Champions event in 2011. I wasn't paying as close attention to that one, I suppose, personally, but as like a milestone in artificial intelligence, this is what we'd call natural language processing. The prompts were shared with the humans and the machine in the same way. Vocal text, if you're familiar with the format of the show. And so for a computer to process and respond appropriately was a big advance in the technology in 2011. And then in 2022, things really start picking up, where I can remember reading this article in the New York Times that a software engineer at Google thought that the tool he's working on has become sentient, which is just astonishing. He thinks that it's self-aware. And ChatGPT takes the kind of public, emerges in public as the first publicly available kind of modern chatbot type tool in just a couple months after that. So I presume that Google, this engineer resigns, and maybe all the other companies working on these were like, oh, if he thinks it's sentient, it must be really far along. And so they probably, I assume they sped to market after that. And people immediately were thinking, what's this mean for education? Is it going to replace the teachers? And some had sort of less helpful ideas about that. Others had more helpful ideas about that. The US Department of Education had released a report which, if you know anything about how these government reports work, this must have been in progress, and then the tools were released, and they just happened to be 5 months after the tools came into public view. But they have this really nice report on artificial intelligence and the future of teaching and learning. And some of the guidelines that I want to point out are related to things like emphasizing the role of humans in the loop as a part of this system, and emphasizing strengthening trust, this kind of using the tools to amplify the things that we know are good practice for teaching and learning, not to just replace. The same question asked of Skinner is always going to be asked as these technological leaps we encounter them. And now look at it. You probably recognize most of the icons on the screen, and just a few years ago they didn't exist. These are all different chatbots, large language models, we sometimes call them LLMs, that are capable of dazzling things. They're suddenly good at things that we've never thought computers were good at, like making art and having a conversation. And they make news when they do something that feels silly that computers have always been good at. You ask it an arithmetic question and it gives you a wrong answer or something. And so it's hard for us to get intuition about what this means as we're sort of learning about these new tools and as we're kind of finding how they fit into our practices. So I'll share just a few remarks about what this means for education. So our team has been, or one of the projects that I've been leading has had some really exciting results, we think, for this human-in-the-loop artificial intelligence, like a pairing between the technology and the instructor team for trying to process free text, like short answer questions that check for understanding. And there's been some parallel research. A colleague at the University of Illinois in Urbana-Champaign, Vimal Rao, and his team have looked at this in the context of statistics, that if we just have the students use an AI tool and to do the computer programming for them, what does it mean for their learning outcomes? And a similar report, actually released at a pretty similar time too, was funded by Anthropic, is one of these large language model and chatbot companies, if you're familiar with Claude. Anthropic is who owns that. So Anthropic has a research fellowship program, and they did a study on how AI impacts skill formation. And they're interested in software engineers. And they showed that in their work, that software engineers who are just trying to get the chatbot to do it for them, to write the code and just keep prompting until it gives you an answer that works, is not doing much for anybody involved. Those that use these tools in a much different way, that they use generate and comprehension type approach, where they prompt it for what they're interested in, and then they're trying to critique and comprehend and understand deeply what's there, and use that in an iterative cycle, are much more successful. And similar to that more high success route are folks that are using these chatbots for conceptual guidance, conceptual understanding, not just asking it to do it for me. And so we're seeing that this isn't an end of homework. It's not an end of teaching and learning, but it's changing how we prioritize and what we focus on with our students. It allows us to pivot towards more of the critical thinking and the problem solving and some of the mechanics, like the programming for this study was in an introductory statistics course, and the students have never done any computer programming, but with the support of one of these tools, they could use that type of an environment productively and learn this and not be distracted from the statistical content that's at issue. And so it shifts our emphasis. And that's been the case with all of these kind of leaps in technology, how they interact with education. But it also often improves access and scale. So it allows us to do things more efficiently for a larger group or to reach a wider audience and equip them with high quality education. And one of the things that I want to caution before I get too far is, so I remember Eliza, text on the screen, the very first chatbot, is associated with a well-known issue that's called the Eliza effect in its honor. And the Eliza effect in the 60s, text on the screen, describes a tendency for us as users to attribute human characteristics to these artificial intelligence tools. It's just black and white text, but people felt like it knows me. It has empathy. They might even use like gendered pronouns when they refer to it. You know, it's very tempting. And so we should be thoughtful about what it is and what it isn't. And some of that is kind of our own maybe carelessness with language of using kind of anthropomorphic terms. Like, it doesn't think the way that we think. It doesn't learn or know things the way that we learn or know them. We sometimes use these words, and it leads us to equate it to kind of human characteristics in a way that can be distracting or disruptive to us. Really, it's a useful kind of way of thinking about it is these large language models, the engine that makes these chatbots go, are a predictive model that's trained in part by some kind of special sauce for the company that's trained them, but also by trying to memorize the internet. And its objective is to try and tell you what you want to hear. And in some ways you might hear that in a pejorative sense, that it's like, tell you what you want to hear, oh, maybe, you know, but it's a predictive model. You've given it a prompt, it's memorized the internet, and it's trying to give you a response that's as close as it possibly can get to what you wanted as a response to that prompt. They're very complimentary, they're very confident. So maybe it's not surprising that they tell you what you want to hear, and that can be useful, but we should regard it for what it is and not be sort of distracted by what it's not intended to do. And I mentioned here that I'm kind of moderate on this scale, just so that I can self-disclose a little bit. But I wanted to share with you a little bit about how this now has been used in the context of supporting teaching and learning. So I mentioned that one of the ways that these leaps in technology have improved teaching and learning is through personalization and tutoring. And so I've been working on a team that's led by Seaman Chow in the College of Health and Human Development. And this work was recently supported by the Social Science Research Institute, an AIC grant. And essentially, you don't need to try and make sense of this whole schematic, but it's putting several tools together that are extending personalized learning for students. iPractice, one of these sponsored programs, was a tool for when there are prerequisites for a course. Maybe it's been a few years since the student had that prerequisite course. And so, yeah, I passed, but it's been a while, and they might need help just, getting to the starting line so they can be successful in the course. And so iPractice was this kind of personalized learning framework that was trying to diagnose where students are at and bring them to where they need to be in order to be successful in the course. T-Practice was a team-based learning extension to that, especially for asynchronous teams. So our object of study there is more focused on Penn State's World Campus courses, where students are in every time zone around the world, and they're working on teams for things, but they're in every time zone around the world. And so T-Practice was an extension of this. And so this new project brings together some of what's working well in I practice and T practice, and extending it with the benefit of kind of large language model support for this AI practice extension. This is just beginning. Jennelle already, shared quite a bit about the Spark self-regulated learning and this team. And I'll also point out, you may or may not be aware of some of these context-aware chatbots that are sort of helping to, or they're intended to help tutor students. Conmigo was a tool from Khan Academy that was one of the early ones to kind of jump into the market. Pearson is a textbook publisher, and I was a consultant for their data science advisory board that we didn't work on this. They revealed to us this AI study tool that they're working on, and it's using context from the textbook, the curriculum, and it doesn't just jump to the answer like other kind of ChatGPT would jump to the answer. It's excited to tell you what you want to hear. You want to know the answer. It tries to lead you kind of breadcrumbs towards more complete, more productive understanding, and anchor you to the texts, the context that you've provided, which is where in the textbook or where in the curriculum, which exercises, have you seen this before? Trying to help you transfer what's going on in the current situation to things maybe you've already shown and learned. And so Pearson is sort of leading the way with this. And NSF is funding other things along these lines. This is an experiment, a project experimenting with what's called constitutional artificial intelligence. Anthropic, I mentioned them previously, they recently published the Constitution for Claude, which is their chatbot. And as you read it, one of the first lines is, you're reading this as though it's written to you, but this is actually written to Claude. It's describing what the guardrails are of how Claude should interact with its users, and what if a user behaves in a certain way that would be irresponsible for what they're asking Claude to do, and how it should respond to this. And it's really interesting. And so they published this because they're trying to be transparent about it. And this team is using a similar constitutional AI approach to establish guardrails to help for a tool that's helping students with writing proofs in a mathematics class. Don't give them the answer. Help them be more rigorous. Tell them when they're skipping steps, or trying to be helpful. And it's just a different approach to how we can implement these things to personalize teaching and learning. And so the team that I've been leading, and the project that I'll spend a little bit the rest of the time kind of discussing with you is, again, I have the big classroom so that you remember this is about formative assessment. So prompts that sort of support learning, not just measuring how people are learning in these large environments, these large enrollment classes. And so the framework sort of looks something like this. And there's some participation coming soon. So if you have a smartphone that can scan a QR code, you can warm it up. So the instructor creates some prompt to check for understanding. And presumably I have some idea of what a complete prompt is going to look like, or sorry, a complete response is going to look like. And the responses that I'm talking about are things that are on the order of just 1 or 2 sentences, short answer type responses. And then the students are prompted to respond to these open-ended tasks electronically. And that's what I'd like to ask you to do. And so here's my QR code. And this is a prototype of a tool developed in collaboration with a team at the University of Auckland. And this has been supported by Penn State, has a strategic partnership. Penn State Global has a strategic partnership with the University of Auckland. And so they have a prototype for this student-facing interaction that we then use or are studying for integrating the type of tools that I've been discussing with you. So when I clicked that button earlier, it just worked, and now it's working. Okay. So we normally students are doing this on a laptop, so it'll be slow and it'll need to open in a Chrome browser. Just this week, Anna Ferguson, one of the collaborators here, was visiting State College. She had to leave yesterday, unfortunately, and just missed us. But she and I kind of flipped this so that it would render reasonably on a mobile device, but it's not very fast right now for you. So I want to show you kind of, the students are faced with this prompt. I've given you a question. I'd like you to play along and just write something, anything. It doesn't make a difference. We'll use it in a moment. And so I might say formative assessment is for learning. And then that'll be my response to this. And if you are playing along, then let's see. See, this is where I get to find out if you're playing along. I do this with my students in class. Oh, fantastic. So we have some folks that are writing things. And so I've grabbed a few of these, and I can look at some of the different things that are being written. I can move them around. I could highlight them. If somebody had said something that was inappropriate, this one's mine, I can get rid of it. That's handy sometimes in these big classes of 300 people that are anonymous. And so now I have all of these. And so there are other tools that do this, to be fair, that can just capture live, some text input to a prompt. But what we have been working on, and please carry on with this because I'm coming back to it in just a moment. But we've been working on has been the approach to integrate some of this large language model support, this artificial intelligence to support this process. So I've given you a prompt, you're writing maybe still your remarks in reply. And then the first pass that we kind of need if we're going to give students feedback is just an overall characterization. Is what the student has written pretty much correct? Like it's pretty much on target with the key outcome, the key learning objective that I'm asking about? Is it maybe they need some support just getting started? They weren't quite able to get started. But there's a lot of ways to be in between. So the partially correct thing is especially interesting to me and to our team, that it could be that, if I'm asking this prompt about the learning objective, a key objective of the course, maybe students are demonstrating a partial understanding, but not quite there. Or maybe they do demonstrate a complete understanding, but then they keep writing and contradict themselves. And so or maybe they represent kind of a common misconception or pitfall that's known for that, to be associated with that concept that we're talking about. And so there's a lot of that we can benefit from even this pretty crude characterization right out of the gate. And so that's a thing that we need technology support for. With this many students in seats, I can't do it all in real time or even overnight. I need some support. And so what we'd like to do is develop a tool. And here I am anthropomorphizing. It's the Eliza effect in action. It's I'm asking for help from this large language model. And it will first evaluate whether that response appears to be essentially correct or partially correct or incorrect based on rubrics that I've written and provided to it. And if it's fairly certain with its evaluation, then maybe we go with it. But if it's not certain, we need a path for it to ring a bell and say, I need a human. And it will ask for support from the teaching team, the instructor or a teaching assistant or something like this. And then together, we reconcile what that outcome should be, and we can characterize whether it's been essentially correct or partially correct or incorrect. And I know that I use the word auto-grader here, but again, it's formative assessment. The grading sort of is a useful mechanism for characterizing that it's doing this evaluative process, but it's not about assigning a grade, and so I don't want you to be distracted by that too much. But does it work? So in our studies for this kind of front half of the process, well, how are we supposed to know if the AI tool is productive in this workflow or not? If it's responsible for us to include it? Well, a natural question is, how good are humans at this? So if two instructors were to review different samples of student writing, would we come to the same conclusion? The answer is, maybe not surprisingly, we don't always, but we agree a lot. And how about undergraduate teaching assistants that are part of the large enrollment teaching team? How often do they agree with the instructor? And it's pretty often, but not quite as much as experts agree with one another. And so now we have some kind of baseline for evaluating if AI or these large language models integrated into the process how they perform, and it's in the mix, which is encouraging. That's good that it's kind of in that domain. But what was really kind of exciting to us and surprising is the human in the loop, where we have this loop that when it has a relatively certain outcome or it has a high probability attached to one of these labels, kind of interpret that as though it's high confidence, then we'll just go with it. And when it doesn't, we ask the human. And the short version of this table is, it's better than either one of us can do by ourselves, which is surprising. Because you might be thinking, okay, well, I know that humans get fatigued and we get interrupted. And so if I'm evaluating hundreds of these in a row, it's not surprising that, that this robot doesn't get fatigued or interrupted. But it's natural language processing. And when we're evaluating the student responses, part of this that was really interesting, challenging, and exciting for our colleagues in computer science, that I guess I took the face bubbles off the screen, but when there's not much text to work with, it's really challenging to do natural language processing. And so when students didn't write very much, those are easy for me. They're easy for the humans. They're very difficult for an algorithm or for the LLM to evaluate. And so it turns out that those were the kind of things that it deferred most frequently, but also we would ask it to defer things just kind of at random. There's nothing wrong with it. We just want to make sure that we're still agreeing and that it hasn't drifted into a type of bias that is not how the humans would evaluate. And so I've been harping on formative assessment. And so students, if they were listening at this point, might be saying, well, what's in it for me? Great, you got this help with evaluating whether it's correct, partially correct, or incorrect. But when do I get some feedback? And this is kind of the next bit of this where I'll introduce another tool. You can play along. Okay, so compare. And what you do, if you need to scan the link, you can scan it again. But if I've done it correctly, you should just be able to refresh the app and something new will show up. And it's called Why So Judgmental? It's comparative judgments. And so students are looking at the different responses in the room. These are, whatever it pulled up for you is different than me, but it's things that people in this room have written for the quick write task. And something happens. I'll come back to this box in just a moment. And then each of us is shown a panel of 3 responses from our peers, and we're asked to put them in order. But you get a chance to drag them in order, and so you're putting them in an order that resembles what you think demonstrates from most complete to least complete, and you're prompted to provide some feedback. And so you're given several panels of these, is part of the prototype tool that we've developed. And so each student might have several of these, and they're writing why is the one that's most complete the strongest in the group, and why is the one that was least complete, like what could be done to improve it. And as you're doing this a few times, you're exercising some evaluative judgment. And this is a higher level of kind of engaging with the content to diagnose what's missing, what could be done to improve this. And you're prompted at the end then, do you think differently about what you wrote to begin with? Now that you've passed some evaluative judgment on peers and have seen how other people interpreted the prompt and have responded, you have an opportunity to then revise or at least re-express the representation of your understanding. And so this is the prototype tool. I wanted you to at least see what the students would see. But where these 2 teams come together, the folks doing the front end at the University of Auckland and our team, which has been doing the back end, the large language model development, is, well, how do we assign you the most productive group of things to evaluate? Is it just the random things in the room like it is now, or is it better if we show you a bunch of people that have written stuff similar to what you wrote? And now you're sort of engaged in something focused on how you've represented your understanding. Or is it better if we show you other misconceptions in the room that maybe you hadn't thought of, but you should engage with? Or there's a lot that can go into how we generate these panels. There's a lot that can be done to prompt you to think more carefully about how you anchor evidence to the prompt you're reviewing when you say something that is a strength about it or how it could be improved. And then furthermore, need some feedback to the instructor in this. Remember, part of this is for the benefit of the instructor to measure if everybody's keeping up and I can carry on to the next topic, or if folks need me to revisit something because there are some misconceptions or incomplete understanding in the room. And so where do we go from here? So there's a lot that's still to be done in ongoing work. This top line is a study that's been funded by Penn State Center for Socially Responsible Artificial Intelligence. And specifically, when I'm doing this prompt in my statistics class, I care about what my students know about statistics. I don't care for example, I don't want it to be distracted by if they happen to grow up in a home that spoke a language other than English, Mandarin or Spanish or something else. I don't care if they're speaking very informally to me, if there's spelling, grammar, or formatting of the response is atypical. This is just me checking for understanding during class. We don't have to be that formal in how we represent things. And so I really want to be sure that students are not disadvantaged by the way they're using language. I care about what they represent as their understanding of the statistics content that's at issue in class. And so this is kind of an important part that's ongoing. And, you know, there's a lot more that I could discuss about this. Using these large language models, many of them are trained with data that's predominantly populated from Western English-speaking cultures. And so there's a real risk that if we aren't attentive to this, that we could have unintended consequences. I mentioned that much of the learning theory is coming from small class environments, and we extrapolate. Well, now we have suddenly this opportunity to turn that upside down, that we have new strategies that are born out of the large enrollment environment. And in fact, if we need to stress test anything, it's how small can the class be where the pool of responses starts to fall apart and there's not enough for us to optimize what we show you. And so we're now looking at the opposite situation, that we need to develop some new learning theory that's born in this authentic large enrollment context and stress test what it would do as it performs in smaller enrollment classes. And there's lots more, but we'll have an opportunity to follow these questions if folks want to do so. But I do want to acknowledge support from National Science Foundation, Penn State Center for Socially Responsible Artificial Intelligence, SSRI, University of Auckland and Penn State's partnership, and appreciate you joining us to talk about this work.
Hello, everyone. My name is Morgan Vincent. I just recently graduated with my PhD in chemistry, and I'm starting a postdoctoral position also in chemistry, focusing on education, and that's why I'm so excited to be here with you today. So I'm going to be moderating your Q&A session. If you have questions on your card, just give them a little wave. Katie's going to come around and while she's doing that, I'm just going to start us off with the first question. So to Jennelle and Matt, I'm wondering if you could tell me a little bit about how undergraduates and graduate students are involved in your research projects, especially because when we think of people joining research, we're thinking about the labs, but we want to also know how are undergraduates and graduates involved in education research?
Thank you, Morgan. Great question. So yes, definitely in the past, I've had undergraduates partner with me. Typically, these may be students who have honor theses that they need to write, but they're interested in education research rather than traditional lab research. So it's been fun to work with undergrads who are deeply education and oftentimes approach wanting to work with me just because they're like, I had this experience, I'd like to learn more about it. So yes, I've worked with several undergrads. I haven't had the opportunity to work with graduate students yet with my experience.
Thanks. That's a great question. So the last couple of summers, I've supervised a team of undergraduate researchers that are assisting with this project, assisting with, you know, part of it is creating the data, of course, that we needed to have data about how undergraduates, how often they agree with an instructor, but also the statistical modeling. And I have undergraduates working with me right now on part of that problem of how the linguistic diversity, how people use language, and whether there are differences in how humans evaluate those responses from students, and whether the differences in how a natural language processing or large language model would evaluate those things. I have also worked with PhD students on this, and one that had worked closely with me on this project is now an assistant professor at Bucknell University, and she was interested in several parts of this that I guess I have the privilege of still a clicker in my hand. But she was really interested in working on the back half of this, how we group these things, how we group student responses, which is an interesting and challenging thing because they come to us as text. And we need to convert that into something that's like a string of a numeric representation that can be used for many of the statistical models that we're familiar with. And so there's a lot of interesting work that's still going on in that area as well.
Great, thank you. So I'm really excited for this next question because as we talk about education, we really want to think about accessibility and expanding the use of our tools. And so this question says, will these tools be available for the general public, for example, high school teachers and other people involved?
Rayne Sperling's work, she does do work with K-12 and has taken tools and incorporated it into the K-12 environment. At this point, my work is focused in the higher ed in the classroom, but that doesn't mean that it could not be expanded to other uses as well, as you mentioned, for the general public or for other levels of education.
Yeah, and sorry.
Getting you have the mic, I'm
I
sorry.
brought my own mic. Is that weird? I don't know. Yes, so especially anything that's NSF funded, those are your tax dollars. So those are always going to be publicly available. And that's, an incentive and a priority for us. And that's something we take very, very seriously. Part of the work developing, refining and training these language models for this purpose, I alluded to this when I talked about we don't really have the training sets that Anthropic or Meta or anybody else used. But we do have some really large data sets we've collected as part of this work, which we will publish. And those will end up being some of the largest available natural language processing data sets for educational research, at least, because others that are doing it, it's proprietary. Apple wants to lock and key their own data so that Apple maintains their advantage. Amazon feels the same way. They're not sharing with one another. And so there's some benefit to even just releasing the data, much more so than the tools themselves. The prototype, the student-facing part, is already used at the University of Auckland. I've used it in my classes, the stuff that you did along with me. But we just haven't done all the plumbing to plug in the LLM stuff, the large language models, to actually do the processing behind the scenes. But yes, that'll definitely be available, and to anybody that wants to use it.
Great. This question is specifically for Jennelle. So since 84% of all Penn State students are exposed to a science course, does that mean that 84% of students are exposed to a course that emphasizes self-regulated learning?
Wouldn't that be wonderful if all 84%, because the impact for that is huge. Think about that. It's not just our students, and we're actually impacting the whole entire University Park campus with the idea of self-regulated learning. I mean, that would be the goal, right? So the Nudge Project has been used in biology classes, statistics classes, physics classes. Dr. Steve Van Hook was here, and he has left, but he's used them in his classes. So right now we are implementing this within the STEM context, not beyond into other courses. But ideally, this would be something that would be seen in all introductory level classes. The students have the opportunity to practice those skills, grow those skills, and then be able to use them and transfer them to other courses, other environments would be our dream, right? So that is the ultimate goal. At this point, we are not at that level yet, but we are doing the work to understand the best practices, the research-based evidence that supports which prompts are most effective, the proper professional development for faculty members, so they're using it properly. Those are all questions that are supported by our funding to help scale this so that 84% of students are impacted and can take that benefit with them on into lifelong learning. So that would be my goal for sure. So thanks for that question.
All right, now a question just for Matt. You were talking about how AI models are largely trained on English native speaking information. So does AI have a built-in translator that can help you better understand maybe non-native English speakers or international students specifically?
So this is a great question. Thanks for asking. And one of the early experiments that we did with kind of an early version of the tools was borrowed from an architecture that was used first in computer vision. So a computer is analyzing some image to declare whether or not there's a bird in the frame. And so you give it lots of different images that some have birds, some don't. There are different types of birds. Some are in grayscale, some are different orientations. And so this sort of, they call it data augmentation, where they sort of, manipulate the image just a little bit to see if how the model will perform. And what we did was something similar with language. And we found that if I had, say, 3,000 responses from students and trained a model on those 3,000 responses from students, I could actually do better, believe it or not, by training the model on 1,000 responses, which had been augmented by translating them to French and back to English again, and translating them to Chinese and back to English again, to perturb the language just a little bit, like the image in grayscale perturbs the image just a little bit. And so this data augmentation approach, we essentially called like a programming backend that is similar to Google Translate. And if they were identical, we actually called a different one just to see if we could kind of perturb the language a little bit. But adding that little bit of noise helped to refine our training of the model. And so there kind of is an approach that can, yes, tolerate if folks are using a different language. But what I'm kind of most concerned about as I was bringing that up is that if their kind of norms accustomed to a different type of language use changes the way they express themselves, I want to be sure that that's accommodated appropriately so that they're not at some kind of a disadvantage just because they express themselves in a slightly different, using a slightly different convention, even if they're using English, but it's because they're thinking of Spanish grammar or Mandarin grammar or something like this.
Thank you. So we learned a little bit about formative assessment, and the question really is, how do we move forward with the best practices in AI? And it's kind of followed up with something also maybe Jennelle might want to comment on, but how do we motivate students to learn and not just get an A? So kind of a two-part question there. A little bit about AI, a little bit about motivation.
I mean, if we solve that today, that would be an incredible thing. So this speaks to some different things. I think that we're still in very early days with a lot of the artificial intelligence stuff, and students, professionals, teachers, all of us are kind of learning how this technology needs to coexist with the things that we are familiar with. And so that part is still a lot to be seen, but I often share with my students that when I started teaching, people were worried about jobs being automated away, and now the temptation to just use artificial intelligence to do your homework is like automating your education away. What employable skills would you expect to have if all you can do is what AI can do for you? ChatGPT is cheap compared to human labor. It doesn't take vacation or call in sick. And so you need to be able to differentiate yourself from what an AI chatbot can do for you. And that's critical thinking. It's problem solving. That's more a make a good decision because it's for your benefit, not because you're trying to see if you can get one past professor, And so at least that's how I approach this topic with my students, especially when there just aren't safeguards in place where the university could sort of, block chatbots if that's what they felt like was appropriate or whatever. We have to figure this out together. And the students, many of them want jobs after they're done. And I find this kind of explanation resonates with quite a few.
Yeah, so I think that's a perfect setup for what I would say in terms of motivation. In our strategic planning for the Eberly College of Science at the undergrad level, one of our focuses in the next 5 years is to really emphasize explicitly the skills you're learning in a classroom, right? It's easy to get wrapped up in the content, right? I'm learning about the blood flow through the heart. I'm learning about this formula. But ultimately, all of our instructors are teaching skills. Critical thinking, communication, right? Whatever those are. We don't do a good job as instructors in telling students that. Or if we tell them, we just don't do a good job of actually breaking down what that means so that they become marketable themselves. So the motivation comes from introducing this into our classes so students understand, as a scientist, I'm not just learning content, I'm learning these skills that I can then market for my next career step, whether it's medical school, industry, research, and be able to say, just like Matt was saying, this is important for me now, because it's going to pay off in the future when I'm going out into the workforce. It's really hard to tell an 18-year-old that, right? That really wants to be in the classroom or downtown or hanging out with their friends. But it's a constant message, and we're working on that consistency to deliver that message across all of our courses. Not only our students, but students in other majors taking our courses understand the value of a science degree and what you're learning in the classroom. So I do hope that will improve the motivation ultimately with that new focus.
Go ahead. So we are out of time for questions, but I think maybe Jennelle and Matt will be around if you had anything remaining.